Good afternoon, students. This is again Pragnesh Polara from Dr. Subhash Technical Campus, Junagadh. Today we are solving the exam paper of GTU 2014 for basic mathematics, right? And we have in the last session we have solved question number 1 for all MCQs and question number 3A, which include the matrix section. Now in this session we are going to solve question number 3B, 4A, 4B, and in the end we will solve the question number 5. So if we look at here the question number 3B, that is solve any two of the following, and the first one is question is given A is equal to, that is 3B. The first example, A is equal to 2, 3 and minus 1, 2, and we need to prove that A square minus 4A plus 7I is equal to null matrix, right? So first of all we need to prove this one, and the second question is hence obtain A inverse. So using this one we need to find A inverse. So let first of all prove this one, that A square minus 4A plus 7I is equal to 0. So here A is equal to 2, 3 minus 1, 2, then A square is equal to A into A, that is 2, 3 minus 1, 2 into 2, 3 minus 1, 2, and that will be 2 into 2, that is 4, plus 3 into minus 1, that is minus 3. Okay, and here again 2 into 3, that is 6. here 3 into 2, that is 6. આપણને બધાને ખ્યાલ છે કોઈ પણ બે મેટ્રિક્સનો મલ્ટિપ્લિકેશન કરવો હોય તો ફર્સ્ટ મેટ્રિક્સની રો સાથે સેકન્ડ મેટ્રિક્સની કોલમના એલિમેન્ટનું મલ્ટિપ્લિકેશન થશે, એટલે કે 2 into 2, that is 4, 3 into 1, that is minus 3, that is 4 minus 3 for the second column, 2 into 3, that is 6, plus 3 into 2, that is 6. Now if we move to the second row, again the same way, minus 1 into 2, that is minus 2, and 2 into minus 1, that is also minus 2, and here minus 1 into 3, that is minus 3, plus 2 into 2, again that is 4. So A square will be, we will get A square, that is 1, 12 minus 4 and 1 by simplifying this one. So now if we move to the A square minus 4A plus 7, we need to prove that A square minus 4A plus 7I, that is equal to null. So here A square minus 4A plus 7I is equal to A square, that we have got 1, 12 minus 4, 1, minus 4 into A, we have A is equal to 2, 3 minus 1, 2, so minus 4 minus here 4 into A, that is 4 into 2, that is 8, 4 into 3, that is 12, 4 into minus 1, that is minus 4, and 2 into 4, that is 8, and plus 7I, that is equal to 7 into identity matrix, that is 1, 0, 0, 1. So 7 into I, that is 7, 0, 0, 7, right? This is A square minus 4A plus 7I. If we look at over here, if we subtract and add these three matrices, then I will get 1 minus 8, that is minus 7, here that is plus 7. So 1 minus 8 plus 7, that will be 0. So first element will be 0. In the same way for the second element, 12 minus 12, that is 0, plus 0, that is 0. So second element is also 0. For the first element of second row, minus 4 minus minus, that is minus minus plus, minus 4 plus 4, that is 0, plus 0, so it is again 0, So 0 0 0, and here 1 minus 8, that is minus 7, again plus 7, so 0. If we simplify this expression, then we will get answer will be 0. So here we will get that s square minus 4a plus 7i is equal to 0 0 0 0, that is null matrix, right? So this is the answer of the first one. And the second question is, hence obtain the value of A inverse. So if using this one, if we want to find the A inverse, then we need to multiply this equation with A inverse both sides. So here if I multiply with A inverse, then I will get A inverse into A square minus 4 A inverse into A plus 7 A inverse into I, that is null into A inverse, that is null. Okay, so here this one implies A inverse into A square, that is A, minus A inverse into A, that is I. This is the property of inverse matrix, that if I multiply the matrix with its inverse, then it will give the identity matrix. So A minus 4i plus A inverse into I, that is A inverse. Okay, this one is equal to 0. So here I will get 7 A inverse. Okay, 7 A inverse, that is equal to this minus 4i will give the 4i minus A, right? So as we all know, 4i, that is equal to 4004, right? Because identity, that is 1001 into 4, that is 4004 minus A, and A is 2 3 minus 1 2. So by simplifying this one, we will get this one is equal to we will get from this one 7 A inverse, that is equal to here 4 minus 2, that is 2, 0 minus 3, that is minus 3, 0 minus minus 1, that is plus 1, so plus 1, and 4 minus 2, that is 2. And from here I will get A inverse is equal to 1 by 7 into 2 minus 3 1 2. So this is the answer of A inverse. So we have solved the first answer of question number 3b, which is, first of all, we have proved A square minus 4a plus 7i is equal to 0 here, and then using that equation we have find the value of A inverse, that is A inverse is equal to 1 by 7 2 minus 3 1 2. So this is the end of first question. The second question is, we have given that if A is equal to in the second question we have given that if A is equal to minus 1 1 minus 1 3 minus 3 3 and 5 minus 5 5, then we need to prove that A square minus A, that is equal to 0, right? So here first of all I will find the value of A square, then I will prove that A square minus A is equal to 0. So first of all let us find A square. So A square is equal to, here A square is equal to A into A, that will be minus 1 1 minus 1 3 minus 3 3 5 minus 5 5 into the same matrix minus 1 1 minus 1 3 minus 3, 3, 5, minus 5, 5. Okay, so let us multiply these two matrices, and we all know, આપને બધાને ખબર છે કે બે મેટ્રિક્સનો મલ્ટિપ્લિકેશન કેવી રીતે કરવું. હમણાં જ આપણે કરેલો સેમ વેમાં જો આ બંનેનો મલ્ટિપ્લિકેશન કરશું તો આવશે. હું એક રો તમને બહુ ઇઝીલી આરામથી સમજાવું છું. -1 ઇન્ટુ -1 આપણે મલ્ટિપ્લિકેશન આ વેમાં કરવાના છીએ. મલ્ટિપ્લિકેશન આવશે આ રો સાથે આ કોલમના એલિમેન્ટ્સનો. ઓકે, સો અહીંયા આવશે -1 ઇન્ટુ -1 એટલે 1, 1 ઇન્ટુ 3 that is 3 એટલે 1 plus 3, -1 into 5 that is -5. Okay, so that will give 3 plus 1 4 minus 5 that is -1. Okay, for the second element the same way, -1 into 1 that is -1, 1 into -3 that is -3, and -1 into -5 that is +5. So this is give 5 minus 4 that is 1. The same way for the third column, -1 into -1 that is 1, 1 into 3 that is 3, -1 into 5 that is -5. That will give us -1. Okay, in the same way if I multiply the second row with these three columns and the third row with these three columns in the same way as I multiplied first row with three columns, right? So in the same way I quickly write what will be the answer for the second row. Here I will get -3 -9 plus 15. Here 3 plus 9 minus 15, and here I will get -3 -9 plus 15. Again this is 3 into -1 -3, -3 into 3 -9, 3 into 5 15. The same way for the second two columns. Now for the third row I will get -5 -15 plus 25, 5 plus 15 minus 25, and -5 minus 15 plus 25. So by simplifying all this I will get this one is equal to -1 1 -1 3 -3 3, and the last one that is 5 -5 5. If we know that here we have get a square that is equal to a, this is our a, so we get a square is equal to a. So if a square is equal to a, then that is quite easy to say that a square minus a is equal to null. So we have proved that here a square minus a is equal to null. So this is the answer of the second question of 3b. Now let us quickly move to the third question of 3b, which is in which we need to solve the equation by the matrix method. The equations are given, that is x plus y plus z is equal to 3, x plus 2y plus z that is equal to 2, 4x minus y minus z that is equal to 7. We need to solve these equations by matrix method, right? This is the third of question 3b. So if we want to solve this by matrix method, first of all I need to convert into the matrix form. So here I will write 1 1 1, the coefficient of x, y and z in the first equation. For the second one this is 1 2 1, the coefficients of x, y, z in the second one, 1 2 1. For the third one 4 -1 -1, right? So 4 -1 -1 into, I will write the variables x, y, z is equal to constants in the right hand side, 3 2 7. This is our a, this is x, this is equal to b. This is ax is equal to b, so we will get x is equal to a inverse into b. So to find capital X, that is xyz, we need to find a inverse into b. So first of all we need to find a inverse. Now we all know that how to find the a inverse from the given matrix, that is a inverse is adjoint of a upon determinant of a, right? So here a is equal to here 1 1 1 1 2 1 4 minus 1 minus 1. So here I am not giving the solution to find determinant here, because we all know how to find the determinant and how to find the adjoint of any 3 by 3 matrix. So here I will directly write here determinant of a, that will be minus 5, and adjoint of a, that will be minus 1 0 minus 1 5 minus 5 0 and minus 7 5 and 1. Okay, this is the adjoint of, this is, sorry, here that is minus 9. So this is the adjoint of a, and this is for check yourself. Okay, so this is for your homework, that is you need to prove that determinant of a is equal to minus 5 and adjoint is equal to this one, minus 1 0 minus 1 5 minus 5 0 minus 9 5 and 1. Okay, so this is the adjoint of a. So inverse of a, that is given by inverse is equal to adjoint of a upon determinant of a, that is 1 by minus 5 into adjoint of a, that is minus 1 0 minus 1 5